Hello and welcome to this instructional video on the Incident Energy Fuse Charts guide that is amongst a suite of 10 tools that are designed to allow a competent electrical engineer to determine the severity of an arc flash incident. My name's Mike Frayne and I'm the creator of the European Arc Guide and the author of the book The European Arc Flash Guide. The fuse charts give a very quick way of determining incident energy for 400 volts three-phase circuits that are fed by HRC fuses that are to the standard IEC 60269 that are commonly used in Europe. These type of fuses are extremely efficient at clearing very high fault currents rapidly and safely when operating in their current limiting zone as shown here. This chart shows a plot of incident energy against prospective short circuit current at the equipment in question. As you can see, at lower current values, the time to operate rises, and as such, so does the incident energy if the fault current is a result of arcing. So, the principle behind the charts is that the area which is outside the current limiting zone of the fuses is expressed as a danger zone. This is derived from a calculation of arcing current and the corresponding determination of disconnection time. This provides a basis for incident energy levels to be established over the fault handling capability range of the fuse. In this case, it's based upon a working distance of 450 mm between the source of the arc and the worker. To access the charts, select the Calculators tab and then Incident Energy Fuse Chart. If you select Expand or Collapse, you'll be able to provide preset configurations which will reduce the need for repeated data entry where the same conditions are being used in several calculations. The second option is to click on Incident Energy Calculator instructions, and this will give you access to comprehensive guidance on how to use the charts. The first field is the enclosure configuration, and there is information given in the guide and in the Incident Energy Tool instructions. We'll choose VCB. Next is the fuse type in question, and we'll pick an NH fuse rated at 400 amps. The working distance is a choice of 300, 450, 600 and 900 millimeters as a distance to head or torso, and we'll pick 450 millimeters. There's much information about distance in the guide, as the relationship between distance and severity is exponential, meaning large changes in incident energy for small changes in distance. On pressing Submit, a fuse chart is displayed for the chosen configuration, fuse and working distance. This is, as you can see, simplified, and there are just two zones. The red zone is danger, where the incident energy is over 16 calories per square centimetre, and the blue zone represents a range of prospective short circuit current where the incident energy is below 1 calorie per square centimetre. I think that you can see the potential of this method in so much that a precise prospective short circuit current is not necessary, and that it's sufficient to know when the value is greater or less than the point at which the fuse operates within its current limiting zone. I hope, therefore, that you find the charts and the guide to be a valuable resource to discover and manage dangerous levels of electrical incident energy in the workplace. Thank you for your time.